Hello everyone, welcome back. The topic for this video is significant figures, and the purpose is to identify the number of significant figures in a reported value. So the importance of significant figures is to tell us how precise the instrument is that we use to record that value. And we will look in more detail in the lab on how to report the proper number of significant figures given different instrumentation. But I do want you to understand that there is an importance behind significant figures. And that, again, is to tell you how precise that your instrumentation is. So if we look at ruler A, if you notice it has additional tick marks in between the integers that ruler B does not have. Okay, and so ruler A is more precise, and therefore it's going to contain more significant figures when you report a value. All right, but in the lab, we're going to be looking at numbers that are already given to us, and we have to decide how many of those digits in that number are significant. And the toughest part is going to be to determine whether a 0 is significant or not. Because if it's a non-zero digit, it's automatically significant. So we don't have to worry about the non-zero digits. It's just those zeros. And we're going to look at 3 different types of zeros. We have leading zeros, captive, and trailing. So when we talk about a leading 0, it's a 0 that comes before any non-zero digit. So the number on the right here has 3 leading zeros before the first non-zero digit, and those leading zeros are never going to be significant. So we do not include those in our number of sig figs. And anytime you hear me say sig figs, I am talking about significant figures. Okay, so leading zeros, not significant. Now let's look at the captive. A captive 0 is going to appear between 2 non-zero digits. So we have an example here on the left where that 0 is sandwiched in between the 3 and the 9. And the captive zeros are always going to be significant, so we do include those in our sig figs. And a captive 0 does not have to be directly sandwiched between 2 non-zero digits. So if you notice here, we have 3 zeros that appear between 2 non-zero digits, a 4 and a 9. All 3 of those zeros are considered captive and therefore significant. So in this number, all 5 digits would be significant, and so we would have 5 sig figs. Okay. The last type of zeros are trailing, and the trailing zeros are the trickiest. So the trailing zeros are going to appear at the end of a number after all of your non-zero digits. And the trailing 0, it's going to depend on whether or not you see a decimal. So in this first number, 3090, there is no decimal present in that number whatsoever. So your trailing 0, which is the 0 here on the end, is not going to be significant because there is not a decimal present. Now in the second example, we do see a decimal. Okay, and it doesn't matter where that decimal is, it's just the fact that I see it. And so if I see a decimal, then that trailing 0 on the end is going to be significant. So in our first number, 3090, the 3 and the 9 are significant because they're non-zero digits, and the 0 in between them is significant because it's a captive 0. So in this first number, we have 3 sig figs. And then in the second number, the leading zeros, if you remember, are never significant. So all 3 of those zeros do not count. Any non-zero digits are automatically significant, so the 8 and the 2 count. And then the captive 0 counts as well, because captive zeros are always significant, and the trailing zero counts because we see a decimal. So there, in this number, we have 4 sig figs. And then in the last example, the first 3 zeros are not significant because those are leading zeros and they're never significant. And then every digit after that is significant, and we end with 6 sig figs in that number. So to review the rules, if it's a non-zero digit, anything other than a 0, it's automatically significant. If the 0 appears between non-zero digits, and remember those are our captive zeros, those are automatically significant as well. If a 0 appears in front of a non-zero digit, those are our leading. Those are not going to be significant. So non-zero digits are significant, captive zeros are significant, leading zeros are not significant, and then the trailing zeros, it depends. If you have a trailing 0 that lacks a decimal point, if it does not have a decimal, then we want to lean on the side that it may not be significant. Okay, so trailing zeros with no decimal, we're going to say that those are not significant. And then the last rule is that if we have trailing zeros that do include a decimal point, those are significant. So trailing with a decimal those are significant. Okay, the last rule that we want to look at are exact numbers. So exact numbers, these are going to only become important when we look at calculations, and specifically calculations with conversion factors. So if a number is determined by either counting objects or by definition, then those are going to have infinite sig figs. And a couple examples is if we count the number of students, eggs, pennies, or any object, those numbers are considered infinite sig figs, and so we don't need to include those in our calculations when determining the number of significant figures. The most important examples are exact by definition. And what that means is that you have 2 units that are equivalent, like there's 12 inches in 1 foot, or there's 100 centimeters in 1 meter. And when you have 2 units that are equivalent and you're setting up a conversion factor, then all those numbers are going to be considered infinite sig figs, or exact numbers. And we'll see in later sections when we deal with sig figs and calculations what that's going to do. Now, if we have a number in a calculator, so let's say that our calculator reports a number back to us as 207.518, and we need to round that off to the appropriate number of significant figures. Well, if we need 6 significant figures in our answer, then it's simply going to be that number right back, because all of those digits are considered significant. If we only need 5 significant figures, so if we need to round the number in our calculator, then we want to look at that last digit and decide if that 1 needs to be rounded up or down. And in this case, because 8 is greater than 5, we're going to round the 1 up to a 2 and be left with 207.52. For sig figs, we're going to look directly next to that 5 and say, okay, the 5, 2 is closer to a 5 than it is a 6, and so we're left with 207.5. And the decimal places are pretty easy, but when we get to 2 sig figs and 1 sig figs, I tend to find that those are the ones that students might struggle with. So let's take a number like 208 and say that we want to round that to only 2 significant figures. Well, 208 is either about 210 or it's about 200. And if we round up, because 8 is closer to 10 than it is to a 0, then we're left with about 210. Okay, so what you do is you're looking again to the right and noticing that that 8 rounds the 0 up to a 1, but we can't say that 208 is about 21. That would be wrong. We have to include the 0 and say that 208 is about 210. And then if we only want 1 sig fig, so if we look directly next to the 2 at that 1, it's going to round it down to 200. The other option is that you round it up to 300. So 300 and 200 both have only 1 sig fig, but 210 is much closer to 200 than it is 300. Okay, so we'd round that down to 200. So this is just teaching you how to take numbers that are in your calculator and how to round it off to the appropriate number of significant figures. So let's look at some examples and decide how many sig figs that we have in each number. Scientific notation. So with scientific notation, the only number that you care in terms of significant figures is the coefficient. And remember, the coefficient we talked about in the scientific notation video is the number before the multiplication symbol. So everything after that coefficient, the times 10 to the 18th, that does not matter so much. Now, normally we would want to say that that is 1 significant figure. And if we were looking at a measurement, that would be correct. But if you notice, we're talking about pencils. So we're not talking about a measurement. We're talking about objects that we're counting. And this is a very large number of pencils. So if we're counting up the number of pencils, then we technically want to say that that is infinite sig figs. But if it were a measurement, we would say that that 2 is 1 sig fig. Okay, now let's look at B. The rest of these are all measurements. We're looking at units. And in B, we know that the non-zero digits are significant. So we know that we have at least 4. The question is, are those zeros significant? And those zeros appear at the end of the number. So we are dealing with those trailing zeros, which was rules 4 and 5. And if you remember, for those trailing zeros, we had to decide if there was a decimal point present. And in this number, there is no decimal point. So if there's no decimal point, those zeros are not significant. No decimal, not significant. Okay, so we only have 4 sig figs in this number. Okay, in the next example, again, we have scientific notation, but we're not dealing with objects this time. We don't care about the times 10 raised to the power. We're looking at the coefficient. And the only thing in question is that 0 at the end. It's a trailing 0, but there is a decimal present. So yes, decimal, yes, that 0 is significant. And so in part C, we have 5 sig figs.